Hello everyone, myself Manasa KV. I am currently pursuing my BE Computer Science Engineering at Sri Venkateshwara College of Engineering. Today I am here to give a presentation for the subject System Software and Compiler Design, in which we are going to discuss a very good topic in that it is Lex and Yacc function. So let's get started. First we will see what is Lex program. Lex program is a program which will convert the source program into a meaningful tokens which are called as tokens or lexemes, which will be given as a output in the Lex program. The Lex and Yacc are the tools which are designed for writers of the compilers and also for the interpreters. This Lex and Yacc will help us to write the program and transfer into a structured input. Lex will have the input as a source program and the output as the bits of tokens, and also these meaningful units which are called as tokens are taken as an input for the next procedure. Here the program with the structured input will have two tasks occur again and again, establishing or discovering the relationship among the tokens. We will see what are the rules of the Lex program. Lex program will follow the particular rules so that it will make the program to get the preferable output which is given as the input to the next procedure. Lex will always match the longest token possible. Here, the lexemes will divide the large structure of the program into small pieces which are having their own meaning, and those are called as lexemes or tokens which will have their own meaning. Example, input ABC. Then A to Z plus matches ABC rather than A or AB or BC. Here plus represents one or more match. If two or more possible tokens are of same length, then the token with the regular expression will define first in the Lex specification is favored. Example, here a small a to z with a plus at the power symbol and the printf as the hello statement. Here when we hit printf world, then the input is given as hint input output as hello. Here we are going to print the hello statement for the output. Next we will see how the Lex program is structured. The structure of the Lex program includes three parts. The first part is called as definition section, second part is called as rules section, and the last part is called as user subroutine. The first part will be enclosed with the percentage and open flower brace symbol. The rule section will be closed with double percentage and opened with double percentage. Then we will see the definition section. The definition section is a place to define the macro or the input header files which are written in C. This definition section mainly include the header files or the variables which are to be declared and which is used in the program. It is also possible to write any C code here. Here definition section mainly have the property of using the C programming language, which will be copied into the generated source file, which will be enclosed with the brackets %C and bracket. Then the rule section. Rule section is the most important section where we are going to make the rules as well as the patterns part. Here the rule section has the two parts like patterns and actions. Each rule is made up of two parts, a pattern and an action, which is separated by a white space. The legs that are legs generated will execute the action which it recognizes the pattern. The patterns are regular expressions. When the lexer sees some text in the input matches a given pattern, it executes the associated C code. It will be open with a double percentage symbol and closed with a double percentage symbol. The user subroutine. The user subsection in which all the required procedures are defined. It will combine main in which C statement and functions that are copied. These statements presumably contain code called by the rule in the rule section. Here we can see the definition section where the header files are taken with the constants and the variables which are declared. And the rule section have actions and patterns which are both are separated by the white space. And here we are going to put our regular expressions and context-free grammars. User subroutine includes the sections where we are going to do a function where the lexems are prepared. Then it is a small program where we are using the Lex program to recognize the numbers. As we see here, the first percentage symbol and open braces are open. That means it's a definition section, and we are defining this rule with a header file. Here header file is #include studio.h, and the header definition part is closed with a percentage and close braces. After definition section in lexical program, we are having the rule section which will be opened with a double percentage, and we are passing the set of rules and the patterns for this. Here the pattern as 0 to 9 to the power plus represent one or more. So here we are having the action as printf saw an integer percentages slash and y text. Here printing the statement as it is seen an integer with a y text. Then it is rule section will be closed with double percentage. After definition section and rule section, the user subsection will be there. That is always a main section. The main section has started with the main and the curly braces. Here we are printing the statement that is enter some input that consists of an integer number. Here it is asking for the input where we need to enter the only integer numbers. The YYLEX will start the scanning of the program to make the program into a small pieces of files, so to produce the tokens as the input for the next syntax program. Then into it is closed with the curly braces. Then we are using into YY wrap. Into YY wrap will wrap all the program and it will return the 1. If it is not used, if YY wrap is not used, then the program is not correctly closed, so that we can get the logical errors when we are executing. It is a programming part. When we come to the execution part, we need to follow and pass the sum of the commands to execute the Lex program. Here to run the Lex program, first we need to put the command as lex1a.l. This command is used to start the writing of the program. Lex1a.l means the .l will represent it's a Lex program. The program name is created where we are going to type the program which I am explained. Then cc lex.yyc. This command is used to check whether the program which we have written has some errors or not. If it has the errors, then after this command it will show us the error with the line number. If there is no errors in our program, then it will ask for the next command. At that time we are wanted to give the next command as ./a.out. This command is mainly used for the output. This statement will be given where we are passed the main function. There we have enter some input that consists of an integer number where it is asking for our input. Here we are given the hello 2345. It is a simple example where you can pass n number of integers as you like. Then we will get a output as which we have mentioned in the rule section as the actions and pattern. We get a saw an integer as whatever the integer we have mentioned in the input which we have given as hello 2345, only integers are taken, that is 2345. This is a simple program. There are n number of programs which we can see and have the hands-on experience. Then we will see what is Yacc program. The first part what I am explained all is about Lex program. Now we are going for the Yacc program. In this program only lexical part is used, not Yacc part is used. Let's see what is Yacc. Yacc stands for yet another compiler compile. That means until the one compiler compile, the another compile need to be waited. Each translation rule input to Yacc as a string specification which will resemble the production of a grammar. Here grammar as a non-terminal on the LHS and few alternatives on RHS, that is terminals are placed at the RHS and non-terminals are placed at the LHS. Simply we can say as string specification as a production. Whenever we are specifying such a strings, it will give us a production. Yacc generates an LR parser for language for the production, which is a bottom-up parser. This Yacc function mainly follows the bottom-up parsing. The parser would operate as follows. For a shift action, it would contain the parser by using the tokens. It invokes the scanner to obtain the next token and contain the parser using the token. Here the tokens are taken as an input to the Yacc program which are produced from the Lex program. Here for the execution of Yacc program, the Lex program must be there and both should be connected. While performing a reduction action in accordance with the production, it would perform the semantic action associated with the production. Here the structure of Yacc program. As we see the structure of Lex program and Yacc program, both will have the same common type except the last. The first part has definition section, the second part is rule section and the last part is auxiliary routines. But in the Lex program at the last we have the subroutine section. Let's see. The definition part includes information about the token used in the syntax definition. Here the definition section of the Yacc program contains the header files as same as the Lex program and the constants which are used to in the Lex definition. Example, percentage token number, percentage token ID. Here percentage token is used because here for the syntax analysis the tokens are taken as an input from the lexical analysis. The lexical analysis which will produce the tokens as the output and it is taken as an input to the syntax analysis. The rules part contains the grammar definition in a modified BNF form. Action in C code is in curly braces and can be embedded inside. The rules part as the double percentage as the open and double percentage as the closing section. The auxiliary routines part is only C code. In the auxiliary routines only C programming is used. It will include the function definitions for every function needed in the rule part. It can also contain the main function definition if the parser is going to be run as a program. The main function must call the function yparse. Yparse will scan the whole program and check for the errors. What will be written on the output file? As we see in the Lex program, like here in the example I have mentioned here, the file name should have the extension as .l. For the checking of the errors we use cc lex.yy.c, and to check the output as ./a.out. In the same way, we are using some of the commands for the output file in Yacc program also. So Yacc program should be named as y.tab.c. The file name will be in the form of y.tab.c. If it contains the main definition, it must be compiled to be executable. Otherwise, definition of the function with the int yparse. If the called with the D option in the command line, then the produced output as the header file y.tab.h is specific definition. If we call with the -v option, Yacc produces an output file y.out containing the textual definition of the LALR parsing table. It will help us to useful for tracking down how the parser will solve the conflicts. Here is a simple example for the Yacc program. Here Yacc program should need to be used whenever we are using the Lex program. Only Lex program is written, but whenever we are writing the Yacc program, we make use of the Lex program. Here to execute the Yacc program, the Lex program is needed and to be connected. Here we have the definition section. We have header files as #include ctype.h, #include studio.h, #define yys type double, and it is closed with the percentage and close symbol. This is a definition section where we are declaring the header files. Then we come to the rule section, which is having the open with the double percentage symbol. Here we are having the actions and patterns as lines s /n represent to the next line. Then we are printing the statement as OK. Then if we have lines as error, yy error is used in the program to check the errors. Whenever we are scanning, whenever we pass the yy error statement, it will check and give the alternative or the message as the error at the last line. Then we are having yes and empty, and we are closing it with a double percentage. Then we are entering into the void function, void yy error with a character *s. Here we are scanning for the error handling. Here yparser will be used to handle the errors which are occurred in the program in Yacc program. Then printf as str_der, and we are entering the main function as auxiliary section int main void, and we are returning yparse. Yparse will start to scan the program and check for the errors, and the error will handle the errors which are obtained. And then the lexical part. This and all belongs to the Yacc part, which will be written with the extension of program name .y. .y represent Yacc program. If the file name .l represent Lex program. Then we are having the Lex program. As I say, it also have a definition section as a percentage open curly braces and percentage close curly braces. Here also it is open. Then we have a rule section as a /t, where we are skipping the blank, where we are skipping the blanks and tabs for this. Then /nt, return yy text. Here slash n represents the next line and it will going to return a YY text as 0, and we are closing the Lex program. This is a Yacc program. For this we are writing the Lex program. Then what is the output we are expecting? This I told you that it is a simple example how to write a Yacc program and how to connect a Yacc and Lex program to get the output. So here I have given a simple example as lines. If it has having the lines, it will print OK, or else it will print the error statement at the last line below the output box. So I connected Yacc program and Lex program. Now I am checking for the output. Write Lex program in a file.l for the Lex program, and for the Yacc program we will write as filename.y. Open terminal and navigate to the directory where you have saved the file. Then we have to type lexfile.l and type yaccfile.y. Then for checking the errors of the program, we are going to type cclex.yyc.c. Then y.cy.tab.h minus ll. This is a command which is used common for both Lex and Yacc. Once we have combined the Lex and Yacc program, connected after connection we don't have the separate command. If we are writing the separate Lex program, it has a separate command. When we are writing the Yacc program, it includes Yacc and Lex. So we use this simple command as type cclex.yy.cy.tab.h minus ll. Then as if I say, for the output we wrote it as ./a.out. So this is a basic introduction about the Lex functions and the Yacc functions and also the simple problem. So thank you for watching. Thank you for